This is an update on the Bunny Science Halo Papper. One question I've been asked is why I wear a surgical mask underneath the Papper while I'm using it in the operating room. And the reason for that is quite simple. The Papper protects me from the environment through use of the anesthesia viral filter. But there's nothing protecting the environment from what I'm breathing out, and because, well, the outlets are just flutter valves and they don't do any filtering. You could put filters in the back of the Papper to filter the output, but typically that's not done. So you have to wear a surgical mask when you're in an aseptic environment. That's why you wear a surgical mask under the Papper when you're in the operating room. You could also put an N95 under there if you want an additional layer of protection, but of course an N95 makes you work a bit harder. A couple other housekeeping things. The availability of fans, especially in this 51 millimeter round rectangular format fan, which I originally specified, is, well, they're getting hard to find. And so it was important to allow other types of fans to be used as long as they have the proper static pressure and flow characteristics. And I did find a 50 millimeter square blower fan. It's in the main project link, but this does not fit the original STL for the fan mount, and that's why the fan mount has been modified. It now has a series of bolt holes and a modified flange to allow the use of either a 51 millimeter rectangular round fan or a 50 millimeters square blower. So either of these will now fit, and as long as the static pressure is somewhere in the 200 to 250 Pascal range and a cubic flow rate of somewhere between 4 to 10 cubic feet per minute, it's likely the fan will work in the system. However, you really do need to check the CO2 clearance in an actual usage setting with gas monitorings to ensure that the fan that you've selected is actually a safe and reasonable one for use with the Papper. I've tested the Papper with gas monitoring pretty extensively, and I've linked a fan on the main page, which is in a 50 millimeter delta. It's slightly lower outflow than the original fan, but even at steady state after 20 minutes, my end-tidal CO2 is fine at 40, and respiratory rate somewhere between 8 to 12, so obviously not building too much CO2 up inside the Papper. You certainly would not want to run with the Papper on board. You can walk, you can do your work as an anesthesiologist, you can go about most light tasks to even occasionally lifting the patient off the table, but this is certainly not a device for heavy activity. Okay, so there's some more changes that we've run into as other facilities begin to use the Papper. One thing that I thought was standard in viral filters was having a male and a female, or inner versus outer diameter 22 millimeter ends. It turns out that's not always true. One of my colleagues in Portland, Oregon sent me, well, he had a problem getting it to fit because his HMEF has a 17 millimeter external diameter and a 22 millimeter external diameter, which does not fit the usual taper, because the taper is expecting a 22 millimeter internal. So the STLs now have a new 22 millimeter internal diameter fitting, which you can use as the alternative to allow this style of HMEF to fit into the system. Another minor thing, the deflector piece for the flutter valves, it turns out these are hard for some people to print. And so the STL has been changed so that the angle is slightly less steep. The overhang is reduced by about 5 degrees, and it's a bit shorter. So this should be easier for people to print and still has the deflection function which you want to make those flutter valves more rapid in function. Again, I have to emphasize, when this papper is working properly, you just don't get a negative pressure in the bag. If you go negative, your bag will collapse to prevent that. And so if you have a big tidal breath which is exceeding what the rate that the fan and filter are putting into the system, the bag, because it's not stented open, it naturally collapses down and acts as your respiratory reserve volume. So your pressure differential never goes negative, and in normal usage, the flutter valves really shouldn't ever close. Okay. One thing which users have difficulty with on this style of the loop was the downward pointed hook engaging the band for the fan mount. Now it's really important to engage the bottom of the hook first. And it's a pretty steep angle that you have to engage it at. So once it's gauged at the bottom, you can then rotate it up over the hook and lock it in place. And that lets you change the height up and down of the fan mount. Now, taking it off is, of course, taking it from the top first, because, of course, we want to disengage the top of the hook first. There. Now, you notice that was not very easy, and some people just didn't have the coordination to handle working with the hook. So the newest version of the Halo loop no longer has hooks. Instead, we have a slot into which the fan band is simply inserted, and you click it at each hole position. Just push it to the depth that's appropriate for you. I think that's a lot easier than the old hook arrangement. The fan mounting band, it's compatible with either the new click slot or the old style hook. But I think this is easier for more people. Finally, wiring up the fan unit. We used to have to use a zip tie or twist ties to secure the loose portions of the lead. You don't have to do that anymore. The frills along the new fan mounting band lets you run the wire through the frills to secure the thin wire for the fan unit. And on the current Halo loop, I'll show you in just a moment. So let's go ahead and put the unit on the Halo loop. I'm going to just go ahead and click it in. There, on that side. We'll click in on the other side. Of course, the fan is blowing forward, and we still have to secure the heavier portion of the cord. We used to zip tie it here to the Halo, but now they're, upside down. 1 second. All right, so now it's right side up, and we'll click it in place. All right, so it's in. There's a Halo. You see out the wire. We used to use a zip tie here, which was a bit of a risk and also an extra piece of equipment you need to have. Yes, you wanted, anytime you use a zip tie, to do a flush cut, and not everybody had a flush cutter handy or a tool for properly tightening the zip tie. So this is nicer, I think, for a lot of people. You still have the hole to allow you to use a zip tie if you need, but now the Halo has this serpentine channel through which you can feed your wire to secure it. You might need to add something here to wedge it in place better if your wire is particularly thin, but this is certainly easier than the old zip tie. But you still have the zip tie option. Anyway, those are some updates for the Halo Papper. It's been very successful in use at my facility. The acceptance in the United States is a little bit difficult with the NIH not having completed evaluation of the units. I am very pleased, though, to report that over 100 of these units are now being printed in India, and I'm told by some of my colleagues in Malaysia that the cost of a commercial papper there is over $2,000 US, and even if they can find the relatively rare papper, they simply can't afford one. And well, we've provided a way for them to have pappers to keep themselves safe, and that really was the impetus for this project. All right, until next time, this is Dr. Kuo at Matrix Anesthesia and Overlake at Bellevue, and stay safe out there.